All right, ratios and proportions. We've been given a specific amount of information here. They've told us there are two people. I've used W to represent a woman and M to represent a man. So we have a person, a 50 kilogram woman, so they've given us her weight, and the ratio of water to mass. In other words, how much water in weight compared to her mass. Her mass is 50, we already know that. And they've told us that the amount of water in her body weighs up to 25 kilograms. This ratio in simplest form is 1 to 2. The man is an 80 kilogram man, so that is the large part of our ratio. And the amount of water in his body weighs up to 48 kilograms. So the simplest form of that ratio is 3 to 5. Now ratios can be kind of hard sometimes to read when they're written side by side. So what I want you guys to get used to doing is setting them up as fractions. And we're going to get into fractions today. The question they've asked us is to find the amount of water in a 60 kilogram man and women. So we have to do the same work for 60 kilogram man and a 60 kilogram woman. Now you'll notice the ratios are different, so the amount of water in a man and a woman will also be different. So I'm going to rewrite the ratios we had above as fractions. I'm going to write the 25 over 50, and that was for our woman, and in simplest form is equal to a half. And for our men, we had 48 over 80, which was equal to 3 over 5. Okay. So these are our simplest form ratios. We want to work with our simplest form ratios. Okay, so in both instances, we're going to be setting things equal to these two ratios or these two fractions. We can, and it's not wrong, to set them equal to the original ones, but because these are larger numbers, they're a little harder for us to work with. So, if you guys recall, this is our weight or mass, and I'm just going to put blue here, the kilograms in blue for mass. Actually, that should be water. That's too different. We'll do mass in red, actually. So 50 kilograms, or 2 kilograms. So our mass is always on the bottom here. Even though we've changed the value of the fraction, mass is on the bottom, so our weight is on the top. Okay. So everything's in kilograms here. So what this is we need to set up our ratio or our fractions on the same levels as these. So for instance, for a woman, the ratio we're going to set equal to it is we have 1 over 2, and water being on top, so I'll write the number in blue, and mass being on the bottom. So we have 1 to 2 is our ratio. We know that the woman in our next example is going to weigh how much? What did the question ask us? 60. Now, is the 60 go on top or on the bottom? On the bottom, because 60 is her total mass. It isn't the amount of water. So what we're looking for is the amount of water. And we're going to use a symbol. Okay, we're going to call it X to represent this unknown amount. Okay? So we've set it up for a woman. We can do the same thing for our man. In our man, our ratio is a little different. It's 3 over 5. And we want to solve it for a 60 kilogram man. The 60 goes where? On the bottom again, because that's the total mass. So the water, what we're trying to find out, is our unknown, which we're writing in blue here. So I've set up two equivalent fractions. These are two different questions. The goal is to solve for our x. When we have two fractions that are equal to each other, they've probably taught you this before, to use cross multiplying. This is the only time we really need to use the term cross multiplying. Okay? And you'll see that later when we go through our other fractions. The reason we're going to use cross multiplying is because it's going to get rid of both fractions for us. It's going to make the question simpler for us to solve. So, when I cross multiply, I'm going to multiply 60 times 1, and I'm going to leave that on the left side of the equal sign. And I'm going to multiply 2 times x. So what is 60 times 1? Give it 1 second. There you go. 60 times 1 is going to give us what? That's right. So we have 60 on the left side is equal to, what is 2 times x? That's right, 2x. We can't really combine them because we don't know what the value of x is in this question. Okay? So, I need to isolate for x. That means I need to get x by itself. Well, because this is 2 times x, how could I move the 2 to the other side of the equation? What's that? What's that? Divide. You would divide. The reason we would divide is because on this side we have multiplication. So when we're moving a number to the other side of the equal sign or the other side of the equation, we use the opposite operation. So if I want to move the 2 over, I divide. And a fraction is division. So 60 divided by 2, does anyone know what that is? 30. That's right, 30. And on this side, we've moved the 2, so all that's left is x. What information have we just learned? What did we just find out? What does 30 represent? And what is x? Water. Yeah, the amount of water in a, what was it, man or woman? Woman. So if we have a 60 kilogram woman, okay, we're going to have 30 kilograms of water, which makes sense. If we reduce this, what is this fraction equal to? 1 over 2. Okay, so we stayed with the same ratio. The ratio stayed the same. Let's do the same thing with a man in this one. Okay, again, we want to cross multiply because we have equivalent. These are equal fractions. What is 60 times 3? That's right. And what will 5 times x be? Very good. Using the same method we used before, what do I need to move? What do I want to get by itself? I want to get x by itself, so I got to move what number? 5. How do I move 5? Good. Same as we did before. So to move 5 over, we need to divide. Anyone know what we're going to get when we divide? 36. That's right. 36. So what does that mean? What have we just found out? The amount of water in a man who weighs 60 kilograms. There's 36. So is there more water in men or women according to this chart? In men. Apparently men have more water in them. I don't know if this chart is actually true. Okay? But the idea was to get used to working with ratios. Okay? And since I told you I want us to get really good with working with fractions, it's easiest if we start to relate a lot of the work we're doing to fractions. So we're relating our ratios to fractions. Or in other words, equivalent fractions.